So at the beginning of every month, I make a post on my Patreon about videos that I'm planning on doing in the coming weeks, and as luck would have it, this time around it looks like I'm basically going to get none of it done. Because there's one question I see coming up over and over and over and over and over again on places like the forum and the subreddit and the Discord and my YouTube comments and Twitter, and after 4 or so years of ignoring it, I've decided that it's finally time to have a crack at it. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about palette swapping. Alright, so palette swapping is an operation which falls under the broad category of color replacement or color adjustment. If you played a lot of classic video games, you're no doubt familiar with the concept, things like shiny Pokemon, or things like the famous / infamous Cloud / Bush from the original Super Mario Bros. That's actually the same sprite with a different palette. If you've ever played a game which allows you to do things like customize your character's hair color, or customize the color of your character's t-shirt, very often, although not always, those things are achieved by palette swapping. The term palette here comes from the concept of like an artist palette, which is going to be like the physical plate, which is going to contain all the colors of paint that an artist is going to use in their painting. And in computer graphics, palette swapping refers to taking one of the colors in an image and just swapping it out for something else. So I'm going to make a little mini-series on palette swapping here, and it's going to be at least 3 videos, possibly 4, on the subject. And we're going to start out from the very basics. We're going to start out from what I actually believe is the first shader I ever wrote. And we're going to build from there. We're going to talk about things like Pixelated Pope's Retro Palette Swapper. We're going to talk about things like Index Color. It's going to be a fun time. So let's start with this duck sprite, right? So this is, as usual, my basic 2D test project. And we are going to, in this basic 2D test project, we are going to start out by just basically changing the color of the duck sprite. I can do that by going into, I think, object obj_player. We can go into the draw event where, like my sprite is being drawn, and we can start playing around with shaders. So let me go and create myself a shader. I'm gonna call this shd_. I don't think that's how you spell palette. shd_palette. We can maximize this. Let's see. I'm going to, of course, want to in the draw event shader set shd_palette, and then when we're done, shader reset. So when we draw our duck sprite or duck object on the screen, we're going to be using the palette swapping shader. So by default, this is going to do nothing, right? So it's just going to take the input colors from the textures that it samples from and reflect them through without making any changes. But we can mess around with this to change the behavior of that. So as always, we can do things to change the behavior of that. So as usual, there's going to be a few things which you're really going to want to know about before diving into the wonderful world of palette swapping. You're going to want to know how shaders work, obviously. I've made some introductory videos to shaders and to different basic operations you can do in shaders, which you might want to go and have a look at if you've never worked with them before. You're probably going to want to have a decent grip on things like how textures work and how GameMaker handles textures, although it's not going to be like... I'll try to summarize the things that you're going to need briefly when we come up on those things later on. It would probably also be a good idea to have like a basic understanding of color theory in general, and while I'm probably not the best person to ask about that, I did make a few videos on how that relates to GameMaker some time ago. I'll have all of these things linked to down in the description and also in a card in the corner. So let's get started with color replacement. So I'm going to just look at the color that comes off of the texture that we sample from in the fragment shader for the time being. We can say var. No, wait, this is shaderland. We have to say vec4. Let's call it sampled color is going to be equal to texture2d gm_base texture and v_v text chord. Every time I see v_v text chord, I think like this is like a like an Eastern emoticon, like it's shaking its head at me or something like that. Anyway, like I said, we're going to start out simple. We're going to start out with a basic color replacement operation, and the way that this is going to work is we can take a look at the color that we sampled off the texture, and if sampled color.red equals, let's say, 252.0 divided by 255.0, and sampled color.green equals 193.0 divided by 255.0, and sampled color.blue equals 18.0 divided by 255.0. This is a very long line of code. I feel like I should have, let's go with a shorter variable name for the sample color, because I don't feel like typing that out every time. Okay, there we go. We are using a shorter variable name. That looks better. Also, this needs to be a divided by and not a minus. Oops. Anyway, so we can say that if our sample color equals a certain value, we can assign that to another value. So we can say sample.red equals, in my case, I'm going to say 0 divided by 255. Sample.green is going to equal... I picked these out ahead of time, so they won't look like... It's not going to look great. But it shouldn't look like complete nightmare fuel. Samples.blue equals 208.0 divided by 255.0. And then when we're done with that, we can say gl underscore frag color equals sampled. And if we want to account for vertex color blending, we can multiply by v underscore v color there. So this might work or it might not work depending on the values that you pick. And I'll explain why in a moment after I run this. So we can now see that our duck has a certain our duck sprite has a certain color value in the middle of it, replaced by blue instead of the usual goldenish yellow. So this might or might not work depending on the values that you pick, and the reason for that is that equality in floating point numbers is notoriously finicky. If you pick values that can be represented, if you're trying to compare values that can be perfectly represented by in base 2 as a binary number, either as an integer or as a floating point number, then you can usually get away with using equality equals on floating point numbers. But if you're trying to represent numbers like 1/3 or like 5/7 or something like that, which can't be perfectly represented in base 2, then you probably are going to run into problems with numbers not equaling each other when they should. GameMaker sidesteps this by using an unusually large like floating point tolerance, which is a discussion for another day, but in shaders that might or might not be the case. This can also depend on things like the precision level that your shader has been compiled with, which is also perhaps a story for another day. But in my case, this worked. In other cases, if you pick other colors or if you're running your game on a device that uses a lower level of precision for its shaders, it might not work. So what you really would want to do if you do something like this is let's define a vec3, which is going to be target color, and I can say this is going to be a vector3 composed of 3 values as usual. One of them is going to be the red color that I wrote out. One of them is going to be the green color that I wrote out, and one of them is going to be the blue color that I wrote out, like this. And now instead of directly comparing the red, green, and blue colors in the sample color versus the target color, we can use one of 2 operations. You can either use the dot product to compare two vector 3s, or you can use the distance function to compare 2 vector 3s. I'm actually going to use the distance function, and I'm going to say if the distance between the sample color and the target color, as if these were vectors representing position instead of color values, if this distance is less than 0.001, then we can do this color replacement operation like this, and that should, in my case, produce pretty much the exact same result. You did not like that for some reason. Why did you not like that? I need to say sample color.red, green, blue, because sampled is a vec4 and target color is a vec3, and you have to use the distance function on vectors of the same size. Let's try that again. So in my case, this will produce the same result, and we should also be able to use this to sidestep things like floating point precision issues. Okay, so I mentioned that this was, I believe, the first shader that I ever wrote way back when shaders were first added to GameMaker. My use case for this involved basically like reskinning window boxes. So if you have a, in my case, if you have like different UI backgrounds for like text boxes or dialog boxes or menu settings or things like this, and you wanted to replace replace colors in the window box. I did something that was basically like this, but I think it had 2 colors or 3 colors instead of just 1. And that was, I believe, the first shader I ever wrote. Nowadays, of course, I wouldn't maybe do that. I would use an actual palette swap, but there you have it. Fun fact about me. So this isn't really all that useful most of the time when you're thinking about palette swapping or color replacement in games. You actually want to replace more than one color. And you could, of course, have a second target color. We can say second target color equals a vector 3, which is going to be, let's pick some different colors this time. All right, again, I picked these colors out ahead of time, so it shouldn't be complete nightmare fuel, but it should, it's probably not going to look great either. If I were to do this a second time and compare the, our sampled color from our second target color, we can pick some more values, which I think are going to be 0, 130, and 241. And you can probably see why this is going to be a bit of a dead end when it comes to palette swapping real fast. So for one, we're just hard coding our color values into our shader, and for two, you're going to have to do like a different hard coded if else block for this for every color you check, which isn't really ideal. You could of course put this in an array, and that would be the second logical place to go after this. So let me define a vector 3 array, and I actually don't remember the notation for arrays and shaders. Is it something like, oh god, this is gonna take me a minute to type out. Boy, writing all that out was an ordeal. So I now have an array of 16 target colors, 16 replacement colors. Those correspond to all of the colors that are actually in the duck sprite, so there's a total of 16 colors in here. Not all of them I'm actually going to replace with this system here, but let's see. We can instead of checking for each one in turn, we can loop over. We can loop over the array of colors to replace, and we can say for int I equals 0, I is less than 16, I plus plus. These are I here is an integer, so not a floating point number, so no 0.0 after that. We can say if the distance between the targets index I and not replacements index I, but sampled the RGB. If that is less than 0.001, then sampled dot red can equal replacements index I dot red, sample dot green, sample dot blue. You can also say sample dot RGB equals replacements, because you can just reassign the vector 3 instead of having to do the operation on individual floats here. And if we do this, now we're going to have something that looks a little bit more interesting. I apparently mistyped one because we're not replacing the one shade of yellow. Let me look real closely at these again. Oh, that needs to be 252, not 255 divided by 255. Okay. So now we're gonna have a see, we seem to have some of the directions have slightly different colors. It's possible that I mistyped an individual color when I put the numbers in the array, but so this is better than what we had before. It allows us to replace the colors in a sprite just by looping over the colors in the sprite, nice and easy, instead of having to do like a separate if else for every individual color, which is not a lot of fun. However, we still have the problem here where this is very hard coded into the shader. And if you were to actually do this, like, this is something that you might actually conceivably do in a game for a color replacement. But if you were to do this, you would probably want to pass this in to the shader as a uniform array instead of hard coding them like this. I'm not going to do that because, to be very honest, I already typed this out once, actually twice if you count when I was setting it for the video. I already typed this out twice, and I don't feel like doing it a third time. And you know what is basically a uniform array of colors in shaders? A texture. The colors that you store inside a texture don't necessarily have to correspond to the actual colors that are going to end up on the screen. You can use textures for all sorts of things. You can use textures for, in this case, we're going to use a texture for looking up the different colors that you want to replace and also the colors that you want to replace them with. If we were to pass in two texture samplers to our shader, we can replace these two big stupid arrays of colors with a pair of texture uniforms. So we can say uniform sampler 2D, sampled 2D, sampler 2D. Let's call it samp targets, and uniform sampler 2D samp underscore replacements. All right, let me try that again. The first time I did this, I made a bunch of hilarious typos, and I had to fix like 4 separate typos before it would compile it, which wasn't a lot of fun. So I'm just gonna start this over. So instead of looping over the array of target and replacement colors as we were doing before, we can now instead loop over the all of the different basically indices in the texture sampler. And the basic idea is the same as we were doing before, but instead of accessing an array, we're going to have to access a texture sampler. So we can say vec3 target is going to be texture 2D. We're going to sample from our samp underscore targets. The texture coordinates that we're going to sample from are going to be a vector2 composed of, let's say, I divided by 16.0. On the x-axis, on the y-axis, it's just going to be 0. We're going to want to make this we're sampling a vector 4, and we're going to want to fit that into a vector 3. So let's just say .rgb of that. I believe shader languages are a bit of a stick in the mud when it comes to typecasting. So we're going to need to explicitly cast integer I to a floating point number if we want to divide it by 16, or we can just define this as honestly a float. Float I equals 0.0, I is less than 16.0, I plus equals 1.0. That might be the better looking way of doing it. We can, instead of checking the distance between an array which no longer exists and our original color, we can check the distance between this target color sampled from the sampler and our target color, and our replacement color can be, instead of another index in another array that doesn't exist, our replacement color can be something that we sample off of the replacement sample like this. And the texture coordinate is going to be the same, because on our two color palettes, each of the indices in these array of colors are going to correspond with the indices in the other textures array of colors. We are, by the way, going to want to slap these on a separate texture page, because it's gonna not work if we don't do that, and I will discuss that more in depth at the end of the video. We're not going to have to do the same for any of the main sprites that we're drawing, so none of the duck sprites are going to have to be on their own texture page. Nothing else is going to have to be on its own texture page, just the 2 palette colors, the palette indices, like this. I'm also going to want to pass those 2 texture samplers into the shader in the first place, so we can say var samp underscore targets is going to be shader get sampler index. That is going to be sht palette. Our uniform name is something which I have already forgotten. Samp underscore targets, like this. We're going to want to do the same for our replacement sampler, and we can get that shader sampler name. We can say texture set stage. The sampler ID is going to be samp underscore targets. Our texture ID is going to be sprite get texture, spr duck palette, sprite image 0. We can do it again for the replacement sprite. We can say samp underscore replacements, and the other sprite name is spr duck palette alt. And now, if I've set everything up correctly and I haven't gone and made any hilarious typos, we now have... Alright, so there is a color in the down-facing duck sprite, which is not in this palette somewhere. I did like automate extracting the color palettes before the video so that we can play around with this and just drop them in ready to go. But this, except for that one, this works. Alright, and it's much cleaner than what we had before with the array of colors. For the sake of organization, if you have a bunch of palettes, it might be a better idea to do one of 2 things. One of them would be to merge these 2 sprites together. So instead of having like 2 separate sprites in GameMaker for different palettes, we can instead let's add a sprite. Is that correct? I feel like that's not the same number of colors that I started with. Alright, I don't know what I copied and pasted the first time, but this is the correct palette. Anyway, you can do one of 2 things to basically merge these 2 things together and make them take up a little less space. Hey. You can use GameMaker sprite subimages to organize the different palettes into a single sprite. And now instead of coming up here and using duck palette alt for that, we can just say duck palette subimage 1 and subimage 2, and that is going to give us the same outcome as before, but without having like a million different sprites for each palette. Or you could take this a step further, and instead of using 2 different subimages for this, you could basically put 2 different rows in the same sprite subimage. So if I were to, let's say, resize all frames, let's make this 2 tall instead of 1, like that. And if I were to copy and paste that into the first sprite image and get rid of the second one, you can now, this also, doing it like this makes it easier to see the like relationship between the colors, like which ones map to which in the alternate color scheme, and also like colors that are the same between 2 palettes. So in my case, that's the colors of the wand and the eyes of the duck sprite. And from this point, we don't need a second replacement sampler. To do this, we can just use the first one. We can sample from the target color is going to be the first row of pixels, y equals 0 in UV coordinates, and our replacement colors are going to be the second row, which is going to be y equals 0.5 in texture coordinates. And now we have our duck sprite, but instead of having two different palette sprites spread all throughout the project, we now just have a single. Anyway, this still isn't perfect. We are still hard coding the number of 1 sprites in the palette and 2 palettes in the sprite, like alternate palettes in the sprite. And it would probably be a good idea if you wanted to like arbitrarily extend the sprite for however many palettes you wanted to include. It would probably be a good idea to let's say uniform vec2 let's call this palette sizes. This is going to be a uniform which I'm going to pass in, which is going to contain the basically the dimensions of the sprite. So horizontally on the x-axis it's going to be 16 because there are 16 colors in the palette. Vertically it's going to be 2 because there are 2 palettes in the sprite. And we can, instead of hard coding these values, we can say I divided by palette size dot x. When we sample from our target, that's still going to be, our base index is still going to be 0.0 because it's going to be the first palette in the sprite. When we sample from our targets again, for purposes of figuring out which palette we want to swap to, we still want I divided by palette size dot x on the x, but we're also going to want something on the y, and we can create a third uniform here for the palette index. That is going to be index 0, 1, 2, etc. that you want to use in the palette sprite, and we can say palette index divided by palette size dot y for our vertical component of this vector 2 here. Okay, let's go assign these 2 uniforms in our all right, you don't need to see me writing out getting shader uniforms and setting shader uniforms for the millionth time. So we're just going to fetch the indices of the uniforms from the shader. We can set the palette size again to the dimensions of the duck sprite, and we can decide we can set the palette index to whatever we want. So if you wanted to be able to let's say see swapping between the 2 duck palettes, we could say like if say if we hold the space button, we could use the duck's original palette, and if we don't hold the space button, we could use the blue palette, and that is going to be a much more general solution to palette swapping in GameMaker. So now when I hold the button, we can see that we are our original colors. When I take my finger off, we are going to use our alternate colors. So that is an introduction to palette swapping. I mentioned that I apparently closed up. I mentioned that if your palette sprites are not on a separate texture page, it won't behave that well. And that is because when GameMaker does its texture packing, let me go into Windows Graphics and then preview the texture pages, and that's going to do do an intermediate build of the project, which is going to allow us to look at how the texture page is assembled. When GameMaker builds your game's texture pages, if sprites aren't marked for their own texture page, they will, in all likelihood, end off in some random location on an existing texture page, and that is going to cause our palette sprite to end up like here, off in the middle of our game's main texture page, and that means that when we go to sample from our palette texture like this, we are going to have to do a little bit more work than this to figure out exactly where on the texture page we should actually sample from. Because if I run this now, we're just going to end up with like nonsense. Actually, we're not going to end up with any swap at all, but you could very easily end up with nonsense if you just did this. And if you wanted your palette sprites to either just be on the same texture page as everything else, or if you wanted to put every palette in your game on a dedicated palettes texture page, you would want to do something like uniform vec2 u text start. Actually, let me call it u palette start uniform vec2 u palette end. These are going to be two new uniforms which contain x, y coordinates on the texture page, where the palette sprites start and end. GameMaker allows you to use a little function which is going to be, what is it? Texture get UVs. No, not texture get texel width. Texture get UVs. This is going to be a function which will return information on the UV coordinates on the main texture page where the actual sprite data exists, which is what we want. The texture ID can be sprite get texture SPR duck palette, like we are using to pass to the shader. We can store this in a variable like this. We can pass these UVs into the shader. What am I going to want to what values am I going to want to use here? Palette start, palette end, and we can say shader set uniform f. Exactly what this returns. This is going to return an array of values. 0 is top, 1 is left, 2 is right, and 3 is bottom. Okay. Let's see. So palette start can be palette UVs index 0, palette UVs index 1 for the upper left corner. Palette end can be palette UVs 2 and palette UVs 3. And back in the shader, let's say vec2 target UVs. I'm going to define this as a vector 2. So we're going to need to find out, like, if our palette index is like pixel 8, right? That's going to be in the middle of our palette index. That's going to be 0.5, so 8 divided by 0.5 because of the number of colors in the palette. So we're going to sample from location 0.50 on the texture. If our palette sprite is somewhere way the heck off else on the other side of the texture page, we're going to need to still be able to sample from the middle of that palette sprite data. And to do that, we could say we're going to sample from the 0.5, so 8 divided by 16, whatever. We're going to say that plus palette start.x. But we're also going to want to multiply this by the span of palette start or palette end.x minus palette start.x, that multiplied by this expression. This is a fairly long expression. On the y-axis, we're going to want to say palette start.y. There is a simpler way that you can write this out, because what we are effectively doing by doing this is a fancy lerp. In GameMaker, the lerp function will linearly interpolate between two values. In shaders, that's going to be mix instead. Why they decided to name it that, I have no idea. I guess you are technically mixing two numbers based on like a start and an end and a fractional value. But anyway, we can say, instead of writing out this math ourselves, we can mix u palette start.x, u palette end.x, and our fractional amount can be I divided by our palette size. And that's a bit of a friendlier looking expression than writing it out the long way. The Y position is, of course, still going to be palette start.y because that needs to be the first line in the palette index at all times. Let's use target UVs for sampling from that texture. We can also do something similar for our replacement UVs. Except in this case, we are also going to want to do a little lerp on the y-axis. Let me put these on multiple lines. We're going to do the same thing on the y-axis, but instead of saying palette start x, palette end x, and the loop counter, it's going to be palette start y, palette end y, and the palette index like this. And that is going to be our replacement UVs. And now this will work if our texture is on its own separate texture page. Apparently it is not. What did I forget? We should be iterating from 0 to palette size for one. I forgot to replace that earlier, but that's not going to be what's going wrong. It looks like I'm still sampling from the wrong location somewhere. Oh, palette size dot y on the y-axis. Okay, it took me far too long to find that. That's how you know you've been staring at code for too long. So, this now works as it does before. It now has the added benefit that you can do whatever you want with your palette sprites. If you still want to put your palette sprites on its own separate texture page, it'll still work. Why you would want to do that if you went to all this work of making it so that this generally works, I have no idea, but you can do it if you'd like. And that is the basis of palette swapping. So this is basically how Pixelated Pope's Retro Palette Swapper works, which is probably the most well-known palette swapper extension in GameMaker at the moment. You could work in some optimizations to this. You can optimize how the texture coordinates are worked out. You might notice that we're doing a bunch of redundant calculations. I don't know if the shader compiler will be smart enough to figure out that, like, this expression here will be the same on every iteration of the loop or not. It might be or it might not be. But there are a couple of ways that you can optimize this logic here, which I'm not going to get into because this recording is already over an hour long. The way that this works is in and of itself not the most efficient way to do palette swapping. We are searching every index in the palette for the color that is being sampled from the sprite. And for small palettes of like 16 colors or 8 colors, that's fine. But if you have larger sprites with more colors in it, then that's not really going to be the ideal way of doing a palette swap. Next time, we are going to venture into the fascinating world of index color. Index color is going to effectively pre-compute the process of searching for color indices in the shader, and it's going to work that out ahead of time, and it's going to encode it into the sprite itself. We're not going to be using this exactly the way that you would have used index color in like the days of the NES or the Super Nintendo or the Game Boy, because like index color as an image format isn't something that we can access in GameMaker. We're going to have to basically imitate it using RGB color, but it's still going to be a lot more performant than doing it this way, but it's going to take a little bit of extra setup ahead of time. Doing something like this is still a viable strategy if you want to drop palette swapping into an existing game, and you don't want to have to pre-process every single sprite in your game to index the colors, but that's going to be a discussion for later. So for now, my name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the GitHub repository down in the description of this video. I will also have links to Pixelated Pope's Retro Palette Swapper and some other palette swapping related resources down there as well. I like shaders and 3D and all kinds of other nonsense, so if any of this appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. These videos do take quite a bit of work to put together, and if anyone wanted to pledge, I definitely would appreciate it. You should all go check out Wizarducks and the Lost Hat, which is the game that I like to work on when I'm not doing YouTube stuff. Link to that can be found down below as well. I hope you all found this useful, and I will see you all later. Special thanks to Zenjamin, VitroV, Squarecrow, SpyDie Games, Manta Ray, GameMaker, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.